part of the interview preparation guide. Today we'll focus on a geometric problem that often shows up on interviews. The title of the problem is Grasshoppers on a Triangle. Let's first define the problem. A triangle is partitioned into 100 smaller triangles by the lines parallel to its sides. And two triangles are said to be neighbors if they share one edge. And the grasshoppers are sitting on those smaller triangles, and at every hop they're moving from a triangle to its neighbor. And 27 such hops happened, and we'll have to show that at the end of such hops at least 10 cells are empty. Now let's look at a picture. So this shows what happens if you draw parallel lines to the sides. So these lines are parallel to the sides of the triangle, and what they do is they create these smaller triangles, and different color schemes are used to show the different types of triangles. So one set of triangles are shown in blue and the remainder in white. The blue and the white are neighboring. So the way the coloring has been done is two neighboring triangles never have the same color. They will have to have the different colors. Now let's look at how to solve this problem. This is a very interesting problem. Let's start with a very small triangle and just have one line parallel to one side, other one parallel to other side, and the third line. And now let's mark the triangles with different letters. The first one, say, mark it with A, and its neighbor marked with B, and the neighbor of B is again A and A. So in this case, the number of smaller triangles marked with A is equal to 2 plus 1 equal to 3. Similarly, triangles marked with B equal to 1. Number of parallel lines is equal to 2 because we have this line and this line. Similarly, we have this line and this line and this and this. So we see some interesting numbers in this case, and let's go to the next level. The steps that I'm following to solve this problem is very similar to the one that you will use for proof by induction. Now let's have two additional parallel lines. And again do the marking. So the neighbors gets different levels. So we have A, B, A, B. Only the neighbors that share an edge will have different levels. If they are not neighbors, they will be marked with the same level. Okay. So going by the same theory, we get the following leveling of the smaller triangles for this case. Now let's count the number of triangles leveled with A. In this case we have 3 plus 2 plus 1 equal to 6. Number of triangles leveled with B equal to 2 plus 1 equal to 3. And number of parallel lines in this case that we drew is equal to 1, 2 and 3. You have to count the side of the triangle as well. So we have 3. Now do you see some interesting observations in this case? First one, we had 3, number of parallel lines was 2. So this number 3 is actually, if you think about it, is 2 into 2 plus 1 by 2. Now how did I get this magic number? Because if you look at it, the way the lines are creating the number of triangles, it's really n plus n minus 1 plus n minus 2. So in this case, number 6 is again 3 into 3 plus 1 by 2. If you have a series of n plus n minus 1 plus n minus 2 plus up to 1, the sum is given by n into n plus 1 by 2. So that's precisely what we're getting in this case. Similarly, for number of triangles with level B, this number can be shown to be n into n minus 1 by 2. by simply doing adding up the numbers as part of the series. So we see that the difference in the number of triangles with level A and the number of triangles with level B is n into n plus 1 by 2 minus n into n minus 1 by 2, and if you compute this is equal to n, which is really the number of parallel lines. Now for this specific problem instance, we had 100 small triangles. Now see how many parallel lines we need to get 100 triangles. So let's now count the number of total triangles. In the first case, it's equal to 4. In the second case, number of triangles is equal to 9. 3 square is equal to 2 square. So total number of triangles equal to n square. So now we got n square equal to 100, where n equal to 10. Very interesting observation, n equal to 10. And this implies that the difference between the number of triangles created by parallel lines is equal to n. So in our case, n is equal to 10, so the difference is really 10. And that gives you the answer, because what happens is the grasshoppers are sitting on two types of triangle to start with. The ones which are sitting on level A, they will move to level B because those are the neighbors, and the ones that are sitting on level B will move to level A because those are the neighbors. Now the number of triangles with level A is 10 more than the number of triangles with level B. So for the first move, the grasshoppers on level A triangle will all move to its neighbors, freeing up all the 55 triangles, because the difference is 10, so it has to be 55 and 45 because the sum is 100. So it will free up all the 55 triangles, and at the same time the ones that are sitting on B will again move to A, so they will only take up 45 places. So that will end up giving you 10 free spaces. Now in the next move, again all the grasshoppers will move back to the level A triangle, and the ones which are sitting on level A will go to level B. So all the triangles will again be filled up. So only in the odd moves we get additional free smaller cells. And if you look at the problem, it says what happens after 27th move. So 27th is really just to give you a hint that the move is odd. So this is the odd move, so that means that we will end up with 10 empty A cells or 10 empty cells, and that's the solution. Hope you enjoyed our solution. Get back to our website at www.wiseguru.org for more such problems with interesting solutions. Thank you.